Commençons par nous présenter. Je suis Vincent Mangin et le collègue avec qui j'ai réalisé cette vidéo s'appelle Alexis Jamet. Nous sommes tous deux des étudiants ingénieurs agronomes à la salle Beauvais. Nous sommes passionnés par les questions d'environnement et d'agriculture, c'est pourquoi nous avons effectué un stage de 4 mois dans le département des sciences de la forêt et des écosystèmes de l'université de Melbourne, en Australie donc. Le projet sur lequel nous avons travaillé s'appelle AGFACE, pour Australian Grain Free Air CO2 Enrichment, ce qui pourrait se traduire en français par grain australien sous air libre enrichi en CO2. Ce programme de recherche australien étudie les effets du dioxyde de carbone sur les cultures. La concentration atmosphérique en CO2 atteindra les 550 ppm, c'est-à-dire parties par million ce siècle. On peut comparer à cela les 395 ppm actuels ou les 300 ppm du début du XXe siècle. Malgré tout, ce gaz à effet de serre est le substrat essentiel à la photosynthèse, mécanisme permettant aux végétaux de fabriquer leur biomasse. Par conséquent, en dépit du changement climatique en cours et de la pression qu'il commence à exercer, la croissance des plantes devra augmenter. C'est pourquoi le projet AGFACE a vu le jour, pour étudier les effets de cette augmentation sur les agrosystèmes et techniques agricoles. Ces recherches permettront de façonner l'agriculture de demain en prenant en compte le changement climatique à venir. Nous allons maintenant voir l'implication qui a été la nôtre dans ce programme de recherche. Michael est notre maître de stage et professeur agrégé à l'université de Melbourne. Il est également un des responsables du projet AGFACE.
How was established the AGFACE project?
Yes, it already started as a joint venture between the Department of Primary Industries, which is the agriculture department of the Victorian state, or was at that time, and the University of Melbourne. And it was originally, the start of the project was funded by what was called the Australian Greenhouse Office, which was a federal government institution that at the time dealt with climate change. And so the site was set up with the help of the Australian Greenhouse Office in 2007. And from then on, CO2 exposure was applied in every growing season.
What are the main discoveries?
Yeah, so far, studying crops under elevated CO2 in itself is not new. The first experiment of that sort, the first in agriculture, was run in the 90s in Arizona. And so at that time we thought, well, it's important to know how much better do the crops grow under elevated CO2, because it will help us to counteract other negative climate impacts and also to produce more food for the growing population and all that. But since then the focus has shifted a bit, and especially in our work we find that some of the originally very positive outcomes have also negative sides. We do find a good growth and yield increase under elevated CO2, roughly across all seasons, about 20% more yield, grain yield. But for example, we also find that these plants would use more nutrients, but they use it less efficiently, depending on how you define nutrient use efficiency, but they would need more, and we don't really know how we could apply more in a sustainable way. They also lose quality, like the grain quality and elevated CO2 decreases, and we showed that in some of our research quite clearly. There was originally a hope that crops use less water under elevated CO2 because it's known that they become more water use efficient. Now our crops do become more water use efficient in terms of growth by water used, but whether the stand actually uses less water is a different question. It seems that it depends on the season. So that's another discovery that's new for the environment we are in, because we are the only experiment of this kind in a dryland agriculture setting, and that makes apparently quite some differences to other results.
What is the purpose of the carbohydrate analysis?
Yes, okay, because you did most of that, so of course that's important. I have to explain how our dryland wheat growing systems work, and that's different from most systems in Europe, except if you go more to the typical Mediterranean, you may have similar areas, because what happens in our system is in the early growing season there is enough water, and then towards the end, after flowering and when they fill the grains, they actually run out of water. And so they often can't photosynthesize during that period anymore. They cannot produce new carbohydrates from photosynthesis because it's so dry. And so it has been shown way earlier that some of the carbohydrates that are used for grain filling, like the starch that is then built up in the grain, comes actually not from direct photosynthesis, like not the leaves photosynthesize and then transfer it right into the grain, but it comes from stored carbohydrates that are stored in the stem from earlier photosynthesis. And so, because that's more important in our dryland systems, plant breeders are already looking at that. So they think that particular varieties that can store more carbohydrates in the stems, they may have an advantage in these dryland systems. And this is still a bit experimental, but it is in breeding programs already in there. Now, if we look at CO2, the importance of that may actually change, because it may be that high CO2 drives or makes it easier for the plants to produce carbohydrates. So maybe these stored reserves become less important. Or maybe plants that can store lots of reserves may even get a bigger advantage, because they can get more carbohydrates, they produce more, and if they can store all of what they can produce early in the season and then reuse, maybe that's even a bigger advantage. We don't know. And that's why we specifically look into this water-soluble carbohydrate story in wheat.
Which plants are cultivated in the first
Yeah, our main, most of our research is on wheat, because that's the most important crop in these systems. But we had for a few years the wheat growing in rotation with field peas, because the rotation system is sort of coming back nowadays as a good way to manage the nitrogen input in a more sustainable way. So we had field peas growing for 3 years, and this year we're growing lentils as a rotation crop, because it's also a legume that can fix atmospheric nitrogen. And we also had canola growing in smaller plots, and this year we have canola in this side experiment, the so-called soil phase experiment. Most of our funding is for wheat, and it's way the most important crop for farmers in that area and in Australia. But we want to learn more about the different types of crop, and having a legume and having an oilseed crop is quite interesting. So our plan would be to run it for another 3 to 4 years, and then have another 1 or 2 year research to really translate the new knowledge into more usable management tools, like better calibrated crop models, for example, or some crop management packages that are really more appropriate for elevated CO2.
Which surface area is dedicated to AGFACE?
Yeah, I should have answered that. Okay, the rings are 16 meters in diameter, the large ones, and we decreased the lentil ring size this year because we didn't get specific funding for lentil research, so we need to save a bit on CO2. So I'll leave you to calculate that. Rings with 16 meter diameter, and we have 4 replicates, that means 8 rings. For wheat is our experimental area.
Ce qui fait 200 m² par cercle et donc une surface totale de 1600 m², à laquelle s'ajoute une extension nommée SolFace spécialisée sur les sols. La technologie utilisée pour les travaux de recherche est la technologie FACE. Elle permet d'étudier les effets du CO2 sur les plantes en plein champ. Ceci est possible grâce à l'installation de tuyaux distribuant le gaz. Les plantes à l'intérieur du cercle sont approvisionnées par celui-ci en fonction du vent, ainsi la concentration en CO2 reste constante et surélevée. L'avantage de ces technologies est qu'elles permettent de conserver les conditions de culture réelles des plantes, sol, activité biologique, climat, tout en étudiant l'impact du dioxyde de carbone sur leur développement. A l'inverse, on crée un environnement spécifique à la plante avec les travaux en serre sous taux élevé de CO2, ce qui entraîne parfois des différences avec la réalité du terrain. Nous nous sommes régulièrement rendus à Enrichment pour intervenir sur le terrain, pour aider à la récolte, et pour effectuer des mesures. Nous allons maintenant vous présenter le travail en laboratoire que nous avons effectué, la quantification des glucides solubles dans le blé. Nous avons travaillé à partir de matériel organique précédemment récolté à Enrichment, comme de la tige ou des feuilles broyées. Nous les pesons, puis nous procédons à 3 extractions de glucides à partir de ce matériel, 2 à l'éthanol et 1 à l'eau. Les échantillons vont au bain-marie pour accélérer le passage en solution des sucres. À la sortie du bain-marie, nous le centrifugeons afin de récupérer le surnageant. Le surnageant est la partie liquide qui peut être isolée de la partie solide accumulée au fond du tube. Maintenant, c'est le tour de l'analyse. Une petite quantité des 3 surnageants est prélevée et mélangée avec une solution d'acide chlorhydrique et d'anthrone. L'anthrone est le réactif qui, au contact des glucides, passera du jaune au bleu. A l'aide du spectrophotomètre, nous pouvons chiffrer l'absorbance de la solution au niveau de la couleur bleue, et donc déduire le taux de glucides de la plante étudiée. Ellie Barami est une doctorante avec qui nous avons beaucoup travaillé à Creswick et à Enrichment. Son doctorat est en lien avec le projet AGFACE.
What is the subject of your PhD?
My subject of PhD is about potative nitrogen use efficiency of wheat and its relationship to soil nitrogen and grain quality under elevated CO2.
Okay, and when have you studied it?
I started my PhD 1st of September 2012.
And so, why have you chosen the University of Melbourne and the Creswick campus?
Actually, I like to do my study and my PhD in Australia, and University of Melbourne is the toughest and the best university in Australia, and it has a high ranking among other universities in the world. About Creswick campus, because the facility which I need for my project, it's elevated CO2 glass house, and here in Creswick campus there is a glass house equipped with elevated CO2, so I should do it here. Also, the Creswick campus is a very friendly and very nice atmosphere.
Which experiments did you do so far?
I finished my first experiment, the glasshouse experiment. It was screening 20 lines and cultivars of wheat according to root depth, root characteristics, and nitrogen use efficiency. And the other experiment, which is in field, it is still running. It's comparing 2 different lines of wheat under elevated CO2 condition regarding to root characteristic, nitrogen use efficiency, and grain quality.